Hey, welcome to this video lesson. In this video, we're going to take a look at separation techniques. And in the previous video, we looked at mixtures and solutions. And in that video, we learned that different states of matter can be combined or can be mixed to form solutions or mixtures. In this video, we're going to learn how to break apart a mixture or a solution. If you have been given a solution, which is a substance made of two or more different substances combined physically, how do we get back the original substances that makes up that mixture or solution? And to start that, first we have to understand something called a pure substance, because if you get back the original substances that makes up that mixture, how can you be sure that they don't contain other impurities? What if the thing that you have gotten is also a mixture on its own? So in short, what I'm trying to say is we have to learn how to tell if a substance is pure or not, so that when we are separating or whatever we get, we can test if it's pure or not. And if it's not pure, it means it is made up of other things which should be separated further. So what's the point of learning how to separate things? The point is just to get pure substances. It can happen that you have water, let's say you want to drink, and you just realize that that water has maybe someone has told you that it's pure water. If you're not sure and if you don't trust that person, you can just do what you're going to learn to test if that water is pure or not. So we're going to take a look at criteria of purity. Criteria is just like characteristics of purity. How can you tell that a substance is pure? So let's define the pure substance. The pure substance is defined as a substance made up of the same type of particles chemically combined. So if water is pure, it should be made of the same type of particles that are chemically combined. For water, it's made of hydrogen and oxygen, which are chemically combined. The only way you can combine those, the hydrogen and oxygen that makes up water, is through some chemical processes that we're going to learn later. For now, just know that whatever makes up water, it is chemically combined. This is not the same with a mixture or a solution. For a mixture, it is made up of one or more pure substances that are physically combined. So, if you mix water and sugar, it's a mixture, and water and sugar have been physically combined. So, the first criteria of purity that we're going to take a look at is sharp melting points. So, a pure substance has a sharp melting point. What does it mean, sharp melting point? We're going to understand what this means by using some graph. And before I can even show you the graphs, the way these graphs are drawn is if you want to test if a substance is pure, let's say it is in its solid form, you get it, then you start heating it. As you heat it, then you have to record temperatures at different time intervals. For example, you can take you can get a stopwatch, then you record the temperature at maybe 0 seconds, then at 5 seconds, 10 seconds, 15 seconds, 20 seconds, just like that. In the process, you're going to have different temperatures and different times. Then you can use that information to come up with the graphs. So let's concentrate on the first graph, which is the graph that shows the melting point of a pure substance. So this axis here, the x-axis is for time, and this y-axis is for temperature, meaning that as you go left, time increases, and as you go up, temperature increases. With that, if the graph moves like this, for example, if we try to get the readings here, we can go down here and we're going to see that time here is greater than 0, because here it's 0. That's where we have started measuring. So at this point, time here will be greater than 0, and temperature here is going to be greater than 0. So as we keep on moving, time is increasing and temperature is increasing. When we reach this point, we're going to realize that further increase in time won't result in further increase in temperature. And if we take a look at our substance, we're going to realize that it has started melting. So when sorry, when a substance starts melting, the temperature stops increasing. You keep on heating the substance, but the temperature will remain constant till the entire substance melts. Once that is done, then the temperature again will start increasing. So the temperature only increases after the whole substance has melted. So that's how a pure substance, that's what it means by sharp melting points for a pure substance. It means at some point the temperature will remain constant till all the substance has melted. So in short, what I've just said is sharp melting point means that when it is melting, its temperature remains constant. Constant means does not change, by the way. The temperature remains like this till it completely melts, and after it has melted, that's when the temperature increases. So this is for a pure substance. What about for an impure substance? How can you tell the deviation from the behavior? Let's say if you have ice that has some sugar in it and you want to melt it, how do you tell that it's not a pure substance? Of course, is if its graph doesn't look like this. So this is the graph for an impure substance. So why is the graph like this? So the secret about testing the criteria of purity is simple. If you have impurities, if you have foreign substances, or if you have other substances that are not supposed to be there in whatever you want to test, when the substances are going to change the physical properties of the substance you are studying. So these foreign substances or impurities are going to change the physical states. Why? For example, if you want to melt ice which has sugar in it, you're going to you need to provide heat to melt both the ice and the sugar. Let's say if the sugar has a low melting point or high melting point, so at 100 degrees Celsius where the ice melts, it will start melting, but not all of it will melt because the sugar needs more temperature. So as you keep on applying heat, that's when the sugar will melt. And of course, it will melt at a different temperature. Maybe the melting point of sugar is 120. So when you reach 120 degrees Celsius, that's when that sugar starts to melt. So at 100 degrees Celsius, water is going to melt. And at 120 degrees Celsius, sugar is going to melt. So that's why the melting point of an impure substance is not constant. It changes as the substance keeps on melting. So in terms of the graph, this is what I've just explained is this. So as you keep on heating, the temperature will be rising with time. Then at some point, the substance will melt, but not all of it, only part of it. For example, if this was water, the melting point of water is 0 degrees Celsius. So if you can reach this temperature, then part of the substance is going to melt. Then but not all of it. As you increase the temperature, as you keep on heating the substance, at a bit higher temperature, part of it is also going to melt, depending on the impurities. And again, as you keep on heating, much of it is going to melt till all of it has melted. Then after that, that's when the temperature will be increasing with time. So that's the difference. For an impure substance, it has different melting points, varying melting points. It cannot have the same sharp melting points. So this is what it means. So as you can see, for the pure substance, this is sharp, but for this, it's not. It keeps on varying. That's when it increases, when maybe the whole substance has melted. So this is the difference between the graphs of a pure substance and the graph of a substance that's not pure. So the second criteria of purity, the other way in which you can know that a substance is pure, is boiling point. So pure substances have sharp boiling points. So the explanation is the same as the one for melting points, which is centered on impurities, and it can be said that sharp boiling points means that when it is boiling, its temperature remains constant, does not change. So everything is the same here. The temperature remains like this till it completely boils, and after it has boiled, supposed to be boiled here, it was a typing error. That's when the temperature increases, which is the same thing. So even the graph, I've got boiling point of a pure substance and boiling point of an impure substance. Of course, the numbers here are going to be different. For boiling point for water is 100 degrees Celsius. For impure substance, maybe to start at 97, 98. By the time it reaches 100, that's when all the water is boiled. It all depends on the impurity, but this is an idea of how the graph looks like. The third criteria is pure substance have non-melting points. So what does it mean to have non-melting points? So most pure substances have been experimented on. People have tried to melt them and have recorded the temperature. So there are values somewhere in the world. They have kept the records of the values. For example, they know that the melting point of water or ice is this. The melting point of steel is this. Just like that, there are those values. And if you have been given a substance, and if you want to taste if it's a pure substance, you melt it and you record the temperature at which it will melt. The only way you can tell that this is the temperature at which this substance is melting, of course, is by physically looking at it. And usually you have to notice the temperature if it remains constant, because at melting point, usually if it's a pure substance, it remains constant, like we're from studying. So at that temperature which you observe to be the melting point, the value should be the same as the standard value that has been kept somewhere. So if you are trying to melt ice, and if you realize that it has melted at 10 degrees Celsius, then that's not pure ice, because pure ice has to melt at 0 degrees Celsius. So this is what it means by having a non-melting point. So this is what I'm just from saying. Pure substance has a non-melting point. This means if its melting point is measured, it should not be different from the known value. The same is true for boiling point. So a pure substance must have a non-boiling point. And finally, density can also be used to test if a substance is pure or not. So pure substances have a known density. What is density? Density is just mass per unit volume, and it's calculated using the formula D is equal to mass over volume. So you measure the mass and you measure the volume, then you divide them. The value that you're going to get, it should be the same as the value that has been recorded somewhere. So if, for example, it's cooking oil, if you want to know that your cooking oil is pure before you can use it for cooking, that cooking oil, you just measure its mass and also its volume. Then you divide like this. The value that you're going to get, you have to look in the books, maybe on Google, to get the density of cooking oil. Then they'll give you the value, and it should be the same. If it's not, then your cooking oil is not pure. It's from the transformer. So that was just a side joke. If you don't understand, it's okay. Yeah. Anyway, if, for example, if you don't understand what density is, in simple terms, you can say if you have been given two substances and if you want to know what their density is, other than just using the formula, just to have an idea of the physical meaning of density, you can just put the substance in water or in any other liquid, and the amount of the substance that sinks will tell you if it's will give you an idea. So density can be used to study filtration, or it's how it is about how a substance can sink or not. But definitely, the base is mass or volume. I'm saying this because we're going to use density and how substance sink or float in liquids to study separation techniques. So I just wanted you to have an idea of density, other than just from the definition mass or volume. So we're going to look at techniques that can be used to separate insoluble solids from solvents or liquids. insoluble, remember, it means something that does not dissolve in a solvent. So if you have a mixture of things that don't dissolve in a liquid or solvent, how do you separate them? For example, if you have chalk in your drink, how can you get back your original drink? I don't know, in your water, how can you back the original Vatra? So that's what we're going to study. So there are techniques, different techniques that can be used for separating insoluble solids from solvents or liquids. The first one is filtration. So this is the easiest and the common one, and is the separation technique used to separate insoluble solids from a fluid using a filter. So a fluid is just a name given to liquids or gases. So both liquids and gases are collectively called fluids. So this is a separation technique used to separate insoluble solids from a fluid using a filter. What are the uses of filtration? So the common use of filtration is purification of water at the waterworks. I'll explain this later. And also manufacturing of sulfuric acid in a process called the contact process. So before I can go, I can give you an insight into these two uses. Let's take a look at the apparatus for filtration. So this is how filtration looks like. So you have a conical flask here, you have a funnel here, and inside the funnel, you can see this brown filter paper here. So this filter paper has got sieves or holes such that water can pass, but solid particles cannot pass. So you get your mixture here, maybe water mixed with chalk or anything. Then you can just pour the mixture into your filter paper. What will happen is water is going to pass and the solid particles are going to remain. So you have your pure water here and the solid particles here. The solvent or the substance that passes through a filter paper is called a filtrate, and the substance that remains on top, on the filter paper, is called a residue. So this is filtration. So in the purification of waterworks, the waterworks, what happens is the water that we drink is taken from lakes, rivers, and the likes. So this water has solid impurities, such as mineral salts, remains of dead animals, and the likes. So for this water to be drinkable, it has to have these insoluble solid particles removed, and that is done by filtration. So the water is passed through some kind of a filter paper, but of course not a filter paper. It works like a filter paper. So once water is passed through that filtering process or filtering mechanism, the solid particles are going to remain, and the liquid, the solvent or the liquid or the water itself is going to pass. So this is purification of water, the waterworks. You cannot forget this during an exam. If they ask you what are the uses of filtration, it should be so obvious. Then the other one is manufacture of sulfuric acid in a process called the contact process. So sulfuric acid is one of the acids actually that are commonly used, and it is manufactured using one of the reactants in the process that sulfuric acid is manufactured is called sulfur dioxide. Sulfur dioxide. So this sulfur dioxide is usually when wherever it is taken, it has dust particles. So this gas has to be cleaned. The dust particles have to be removed in this gas. Therefore, we use filtration. We just pass the gas on a filtered mechanism like a filter paper. So the dust particles are going to remain, they'll be trapped. Then the gas is going to penetrate. So that's one use of filtration. Manufacture of sulfuric acid in a process called the contact process. So before we make sulfuric acid, we have to make sure that what is used to make sulfuric acid, which is sulfur dioxide, is clean. So this is one of the separation techniques that are used to separate insoluble solids from solvents or liquids. The next separation technique is sedimentation. Sedimentation. So what is sedimentation? This is a separation technique used to separate mixtures of insoluble solids in a solvent or liquid by shaking the mixture thoroughly and then allowing it to settle. So this is a very simple technique. What you do is, by the way, we're going to, I want you to not forget the meaning of the word sediment, as I'm going to show you. So if you have got a mixture like this, let's say this is a cloud mixture or a suspension of chalk and water. So what you do is you shake this mixture, then you leave it here. You allow it to settle. So after some minutes, depending on the density of chalk, by that I mean if this chalk is heavy or the particles of chalk are heavy, they are going to go down fast. But if they're not heavy, it might take time because they are not heavy to sink down here. So after some minutes, you're going to have a clear liquid on top and the insoluble particles on the bottom. So this is sedimentation. These solid particles, insoluble solid particles at the bottom are called sediments. So this is sedimentation. That's all. You have got a pure liquid on top and the insoluble substance on the bottom. The next process is the next technique that can be used to separate insoluble solids from solvents or liquids is called decantation. So decantation is the separation technique used to separate a liquid from sediments. So decantation is usually done after sedimentation. Once you have this, you can now decantate. So what is to decantate? To decantate is just to remove this clear liquid on top. So you do this by carefully pouring it out into another container or another beaker. So once you do that, you have done decantation. As simple as that. So once you do sedimentation, then you can do decantation. So what are the uses of sedimentation and decantation? So one application of these two techniques is the separation of wine from its sediments. So when wine is made, it has some solid particles in it that comes from the fruit it was extracted from. So these insoluble solid particles in it have to be filtered or to be removed, and this is done by decantation and then sedimentation and then decantation. You allow them to settle. Once they settle, they go down. Then you pour out the wine from the mixture. Then you have separated wine from its sediments. So the next technique that we're going to take a look at is called centrifugation, and is defined as the separation technique of separating insoluble solids of different densities that are in a liquid using an apparatus called the centrifuge. So if you have one or more insoluble solids that have different densities mixed in a liquid, you can separate them using what is called a centrifuge. So a centrifuge looks like this. Forget about the outer part, this container-like part, just concentrate on the inside. So inside the centrifuge, down here, there is a motor which we cannot see. This motor, once the centrifuge is started, is going to be rotating the upper part of the apparatus. So the upper part here, this ring part here, has where you can insert the test tubes. These four are test tubes. So you can insert the test tubes and you can remove the test tubes. So once, this is how the centrifuge works. So if you want to separate your mixture, you can remove the test tubes. You put your mixture in these test tubes. Then you can reinsert the test tubes into the apparatus. Then you can start your centrifuge. Once you start your centrifuge, the upper part of the apparatus is going to be rotated. The rotation is going to provide what is called a centrifugal force, or a force that's going to throw the insoluble substances to the bottom of the test tubes. So if you have different substances that have different densities, the one that is dense is going to be thrown first, followed by the one that is less dense, just like that, and the solvent will be on top. That is after all is done, you're going to have a clear solvent on top. Once the parts of the mixture are separated, you can remove the test tubes and you can then decantate the solvent so that you remain with the insoluble solids. So this is how centrifugation works. What are the uses of centrifugation? So I'll just give one example, which is a very good application of centrifugation, and it is done in the hospitals. So it is used in hospitals to separate the red corpuscles from the plasma in blood. So blood has got the solid part and the liquid part. The liquid part is called plasma, and the solid part of it is the red corpuscles. So if you want to analyze blood, for example, or if you want to separate the liquid part of blood from the solid part to remove these red corpuscles, you can use centrifugation. So you can just put your blood sample in the test tubes and rotate. At the end of the day, you're going to have the red corpuscles on the bottom and blood on top. So from the last explanation, you can tell that you can use centrifugation also to separate an insoluble solid from a liquid. This is preferred to sedimentation when the insoluble solid is not denser. Imagine if you want to use sedimentation for a solid that is not denser, it will take time for that solid to sink to the bottom. So to quicken the process, what you do is you can just put your mixture in the test tubes here. Then you start off the centrifuge. You start the centrifuge. Once the centrifuge is started, you are going to have the insoluble solid at the bottom and the solvent at the top. So in summary, centrifugation is used to separate insoluble solids of different densities that are in a liquid, but it can also be used to separate an insoluble solid from a liquid, provided that the insoluble solid is less dense. Or even if it's denser, it can work, but it is preferred over sedimentation if it is less dense. Next, we're going to look how to separate liquids from liquids. We're talking about immiscible liquids first. So we use an apparatus called a separating funnel to separate immiscible liquids, such as oil and water. So this is how a separating funnel looks like. So just put your mixture in the separating funnel. So since these the immiscible liquids have different densities, and as we then immiscible liquids tend to form two layers, so they are going to form layers. The denser liquid is going to be on the bottom, and the less dense one is going to be on top. Once you have this, you can use this this topper here. It's like the tap where you can turn it, and then the fluid will flow. So you can just open this stopper here, and the denser liquid is going to go down. So you can collect this by putting a big or in container here, and you have your denser liquid. Then this less dense liquid will just be the one remaining in the separating funnel. So this is how to separate immiscible liquids. From here, we look at solids from solids. How do we separate solids from solids? So the main idea of separating solids from solids is or depends on the physical properties of the two solids that are about to be separated. Given two solids, and if you have been asked to separate them, ask yourself what physical properties do these solids have, and look for the one which they do not share, or that is just unique to one. For example, I can have this solid which behaves like this, but the other solid does not behave like that. So you can use that as a criteria of separating. You're going to see all the techniques that are going to be presented in here. They depend on the different physical properties of solids. So sublimation. So sublimation, if you remember, is the change of state from solid to gas and from gas to solid, direct without passing into a liquid. So how do we use sublimation to separate solids from solids? Sublimation can only be used if one of the solids sublimes and the other does not sublime. So this is the difference in the physical properties that I was saying. So this can only work if the two solids have got a difference in physical properties, and that difference is one sublimes, the other does not sublime. So this is used to separate a solid that sublimes from a solid that doesn't sublime. An example of a process where we can apply sublimation is this. So I've got a Bunsen burner here, we've got a wire gauge here, we've got a tripod stand, and we've got mixture of iodine and common salt in here. So to separate this, what you do is you heat the mixture. As you are heating the mixture, the substance that sublimes is going to sublime. In this case, it's iodine. If you remember, we learned about some examples of substance that sublime, such as dry ice or solid carbon dioxide, ammonium chloride. Other examples are iodine and naphthalene. So iodine, when heated, it's going to turn into a gas. Then as it is going up, it will meet this part, which is colder as compared to this part, and the gas is going to sublime back to a solid, and we're going to have solid iodine here and here. So we can separate these two, and so that we extract the iodine, and what's going to remain here is common salt. So that's how sublimation works. For this actual experiment, just be careful on how to handle this, because it can happen that we have got vapor or gaseous form of iodine, which is very poisonous. So you have to make sure that you handle this in fumed cupboards, so that the gas does not escape. So another process that is used to separate solid from solids is called flotation. So this is entirely based on density. If you have two solids that differ very much in density, then you can use flotation. If, for example, you have a piece of wood and a piece of metal or steel, then you can use flotation, because one might sink into the liquid and the other one might float. So you can use flotation. You can just put all of them, they are in the liquid, one sinks, the other one floats. That's how flotation is done. So flotation is a separation technique used to separate solids based on their different densities. The two solids are put in a liquid and one floats and the other sinks. As simple as that. Another technique that is used is magnetism. This is the last technique we're going to take a look at in this part of the video. So magnetism is used to separate magnetic substances from non-magnetic substances. Again, the physical property that's going to be used, that is used in magnetism, is being a magnetic material or not. So a magnetic material is attracted to a magnet, and a non-magnetic material is not attracted to a magnet. So if you have two solids which where one is magnetic, the other one is non-magnetic, then you can use magnetism. So what I've just explained is this is used to separate magnetic solids from non-magnetic solids. So an apparatus of magnetism is like this, where you have a petri dish and you have got a mixture of a magnetic material and a non-magnetic material. In this case, you have iron filings. I know the labels are not clear, but it's okay. Just follow my explanation. So this mixture is made of iron filings, which are magnetic, and sawdust, which is not magnetic. So when you bring your magnet here, the iron filings are going to be attracted. So all of them are going to be removed and they're going to remain with sawdust. This is a technique that kids of nowadays are now using to identify. Let's say you lose a coin and it sinks in the dirt. How do you get it back? You just get a magnet and pass it on top. Then the coin is going to get attracted to the magnet. So that's pure application of separation techniques, and the process is magnetism. So this marks the end of this lesson. Check out the next and last lesson on separation techniques.